Welcome to our fourth Back to the Basics webinar. Today we'll be talking about influenza tools and our sequence submission. Here you can see our LinkedIn QR code, and then our last Back to the Basics webinar will be about analyzing protein data. You can find the information on the BV-BRC homepage. My name is Anna Capria. April and I work on the BV-BRC project on the viral team. I am the outreach coordinator, so I manage things like giving you these webinars and help field any requests or concerns that you may have. We're always trying to make the resource as useful as it can be for you. So please feel free to reach out if you ever have any questions or things that we can make a little bit more useful for you. I have a master's degree from the Keck Graduate Institute, and I did my undergrad at RIT, and I spent some time at Uppsala University as well. And April and I both work at JCVI, which is one of the 5 organizations that come together to bring you the BV-BRC, and I'll talk about that at the end. And now I'll let April introduce herself.
Hi, my name is April Suniga. I work with Anna on the BV-BRC project at JCVI. We're both part of the viral team. As a graduate student, I attended San Diego State University, and as an undergrad, I went to UCSD. My major was biochemistry, and at CSCU, I went for bioinformatics.
Hopefully you are familiar with the BV-BRC, but if you aren't, we are an NIH-funded resource to support the bacterial and viral communities for having the data about the pathogens, and then also bioinformatic tools to make accessing that data and analyzing your own data as useful as possible. So over the course of this Back to Basics series, we've covered the data as a whole, our phylogenetic tree service, and the sequence annotation and assembly. So just really kind of getting you comfortable with some of the core services that the BV-BRC offers. And those recordings will go up on our YouTube, and you should be able to access those. So that's kind of a high level what the BV-BRC is. So we support the diverse bacterial and viral community. We have a unified data model and real-time data integration process. So every day data from Genbank is uploaded into the BV-BRC. We started a new series on our social media where you'll see weekly counts of the data that's being ingested. So you can see that every day there are more and more sequences added. On a week, you should see how much it grows. So if you're interested in following that, definitely keep up with us on social media. We bring the data in with annotations and do a lot of curation efforts to make sure that that data is as searchable and useful as possible. And then we have a bunch of different tools to help analyze the data from Genbank and your own data. And if you're doing a lot of large-scale analysis, we do have our APIs and command line interface to pull that out or upload into your tools. That's something that we can host another webinar on if people are interested, but definitely something that exists in the BV-BRC with help documents if you're interested to learn more, and then outreach and education like this. The next slide is just going to be an overview of the services that we're going to talk about, and April's going to tell you about the sequence submission tool, then I'm going to tell you about our HA subtype number conversion, and then we have some surveillance data that we want to go over. So I'll hand it over to April to talk about sequence submission.
The objectives for this talk is I'm going to briefly cover some statistics about influenza. We're going to describe the BV-BRC tools that Anna just mentioned, and then how to upload the required files and submit a job, and also briefly go over the results. Influenza or the flu is a highly contagious respiratory illness caused by flu viruses that infect the nose, throat, and sometimes the lung. Influenza is detected year-round in the US, but it's most common during the fall and winter, where it can lead to lots of hospitalizations and sometimes even death. Each year, an estimated 3 to 11% of the US population gets the flu. And then during the 2019 to 2020 flu season in the US, the CDC estimated that flu was associated with approximately 38 million flu illnesses, 405 hospitalizations, and 22 deaths. So the sequence submission tool, the goal is to allow users to validate and submit viruses sequences to NCBI Genbank. There's two main steps in the sequence submission process, the validation and annotation. The validation steps compare the sequence submitted against Genbank submission standards to identify sequence errors. And then the annotation uses Figure4 and the flu annotation tool for internal use by the users. This is a very brief summary of the steps. I'm going to go over these steps and then I'm going to switch to the BV-BRC page. So the first step is to specify the parameters. The fields that have an asterisk are required. It requires information from your consortium. It requires an address. It requires your name and an email. And also asks for the input files. The input files are a metadata file in CSV format and a FASTA file. Then step number 2 is to submit your job. Once your job has been completed, you will get 13 output files if your job was successful, including a sequence validation report in CSV format. This is a validation of results for all the sequences that you have submitted, and it allows you to review your segment, serotype, status, and messages determined by the annotation tools for each sequence identifier. And then lastly, you will notify the BV-BRC team that your submission is complete and ready to be submitted to Genbank. Now I'm going to switch over to the BV-BRC page. So this is the homepage for the BV-BRC website. In order to access tools and services, you must be logged in to your account. So you go to the sequence submission tool found here. The first name, last name, and your email will be auto-generated. It only supports influenza A, B, or C. Here you can find a very helpful tutorial and then a quick reference guide. I'll start filling out this part first. So the phone number won't show up, so you can provide your number. I'm just going to put an example here. And then your institution and affiliation, mine would be JCBI. The consortium is not required, so I'm going to leave it blank. And then the street, postal code, city, state will show up on your Genbank record. So this is asking for your affiliation address. So this is the address for JCBI. 9237. Your city, state, any country is required, so I'm going to fill the country. So this is the submitter information. The next step would be to select the FASTA file and the metadata file. So here there's an example of the metadata file. I'm going to download that. It takes you to the BV-BRC website that has the templates for this tool. So let's look at the FASTA file. There's multiple ways in which you can download the files. So let's look at this. This is an example of the FASTA file. So it has a unique sample identifier that says sample ID and then a unique sample identifier with the sample ID. I'm going to go back to look at the metadata file. So this is the example of a metadata file. I can double click on it. And then I'm going to select the first row contains the column. I want to look at this. So this is the sample identifier. It has a sample description, the organism, sequence type, the author, publication title, and all the fields that are required in your metadata file. Again, you can look at this. I'm going to go back to the home page and take you to that page again in case that wasn't clear. So you go to sequence submission, and then you click here to download the meta CSV template. So these were the two files that I opened. I'm going to go back to the sequence submission page. And once you've filled all this information that's required, you have two options here. So you can paste your sequence or you could select your FASTA file. For this example, I'm going to select my FASTA file. Again, here are multiple options. You can scroll through multiple FASTA files that are in your workspace. You can search for them here. For example, I have my FASTA file in webinar. I'm going to select the sequence, hit OK. and that selects my FASTA file. Another option is to upload your file from your computer. So you can browse through your computer here. And then the metadata file. So my metadata file is in the same location as my FASTA file in my workspace, in the webinar folder. I'm going to select that and hit OK. So now I have my FASTA file, CSV. Now I'm just missing an output folder. Where do you want your results to go once the job is completed? I'm going to highlight the folder webinar. You can also browse through different folders here. And the output name. And then the last step is to hit annotate and validate sequence. Now you'll see that my job should be running. If you click down here, you can see your jobs that are running. It takes a bit to refresh, but here, this is the job I just submitted. And the BV-BRC team gets a notification that you just submitted a sequence submission. However, that doesn't mean that your job is going to be submitted. I have an example here of the result that I'll go over. The next step, you will get all of these files. This file is the input FASTA file that you just submitted. This is the metadata that you just submitted. And then this is the file that we're interested in, the sequence validation report that the user has to go over before the file is ready to be submitted. So this is what it looks like. You got the sample identifier, the segment, the serotypes, and the status. You also get messages when there's a warning or an error. Sometimes the error does not mean that Genbank is going to flag it. It just is an indicator that maybe you should go back and check your sequence before it gets submitted to Genbank. For example, all of these are valid in an indicated segment. So there's no red flags in this submission. So the next step, when your file looks very similar to this, you can go back to your sequence submission. So you go to your home page where your job was submitted, and then you click on Submit Sequence. This is the last step. Then the BV-BRC team would get a notification that your sequence is ready to be submitted. And then within 1 to 3 days, you will get back your Genbank identifiers from one of us. I'll let Anna continue. That is all for the sequence submission.
Just a question. So are there any errors that you run into with people submitting sequences that are common things?
Yes. For example, sometimes there's an error, and since we still receive the notification of your sequence submission, if there was an error, we like to look at what the error was. So for example, one of the last errors that we got was that there was an ASI character in the sequence submission. So we got a flag for that. So we went back and looked at that and told the user, oh, you had an invalid character in your sequence submission. That's why it failed. So we do look at failed jobs and try to fix them as soon as we can.
Mary's asked a few questions. Yeah.
Okay, for the ones who are, did they move forward to submission or are they blocked? So there's two types of errors. The errors that you get on the BV-BRC page, that's the one that I was talking about, for example, with the ASI character that was invalid. We did contact the user and told her, oh, you have an invalid character. Please resubmit your job without that character. And then there's sometimes when we submit the sequences to Genbank, Genbank tells us, oh, there's a mutation at the start. We can't accept your sequence. In that case, we also go back to the user and let them know, oh, Genbank flagged your sequence because you have a mutation at the start. Please review your sequence and we will resubmit. So in both cases, we do contact the user and try to get the sequence to be successful. And then the other question, the submitted file, is there confirmation was successful? Let me look at that file. I usually do not look at this file, but I can't open it. I will get back to your question, Matt. Let me try to open that file and then I'll answer your question.
And then did we look at the metadata example file with the columns that have very specific formatting? I know that that's a discussion we've had internally.
You can see an example of a metadata file if you go to the service and then click here to download the metadata CSV file. So I click on here and then this is the CSV file.
And so that will have good
There's
description of how each column needs to be formatted.
Oh, sorry, I did not open that file. This is the standard details of the metadata file that I can download and open. Thank you. I forgot about that one. So this Excel file contains examples of each part of the metadata file. So the sample identifier should look something like this. And then the sample description, the organism, and it tells you there's a max length of 100 characters and a description or a definition of the input type. This is all found within the same folder in the BV-BRC page that has the FASTA file and the CSV.
I think we'll move on to the HA subtype numbering conversion. The next service that we want to introduce you to is the HA subtype numbering conversion. And this takes in influenza HA protein sequence and converts the position in numbering to a different HA numbering scheme using the David Burke and Derek Smith method. That takes in both sequence and structure information to propose positions of functional equivalence across different HA subtypes. From the user, we need protein sequences, and then the sequence is blasted against the Burke reference sequences, which determine the best reference subtype to be used in the pipeline. Then we do a multiple sequence alignment, generating a pairwise MSA using reference protein sequences, and the inputted protein sequence. Then they're mapped between the user input and then the references. Then results are generated of that whole process. Step one is to specify the parameters that you're going to use, so the input files and whatever numbering scheme that you want to map to, and then submitting the job, and then reviewing the output files and visualizing the results. So what that looks like on the BV-BRC is that under Tools and Services, you're talking about the HA subtype numbering conversion protein tool. And so for the purpose of this example, I just pulled an HA sequence from the BV-BRC Influenza A genomes, but you're totally able to select your own FASTA file or some other one. So I'm just going to show you how you can find that data and pull it right from the BV-BRC database. But again, this is something that you can use on your own data. Under organisms, I'm starting on Influenza A, which is one of our featured viruses, which is just to easily get you to be able to click on it. So I clicked on Influenza A. Then I'm going to go over to the Features tab. And if you're not as comfortable searching through the BV-BRC tabs and things, I would recommend checking out the first webinar that we did. And it took a second to load because we're loading over 1 million features. So sometimes it takes a second. Just be patient with the database as it's loading data. Since this tool works on HA segments, we want to be able to pull out just that feature. So you can see when you click on the gear, like I did, there are a few search criterias that are automatically generated, but you can add other ones to make it more able to be searched. So for this, I'm gonna just click on the product and type in HA. And then gonna scroll down to, actually had a test one open, but I just wanted to show you like kind of my process for how I got the sequence that I'm gonna use. And so if you click on any of these rows, you'll see that the green toggle bar is not always going to be the same depending on what you're looking at. So that's just something to keep in mind, that the genome view of this green toggle bar might have different features than the feature view or the protein one. So just always check that to see if there's any additional functionality. One of the things here is the FASTA. So you can view the FASTA proteins, and that will just take you to the FASTA file that you can copy and use in the tool or use for whatever purpose you need. And then you could also download that FASTA to do your analysis. So I'm not going to copy this one over just because I used a different one for the test example, but that is something I can totally just copy and paste for your use. So if I copied and pasted, you could just put it in here. But you can also select a FASTA file from your workspace. But I put the FASTA file that we're going to use in a feature group. So just going to go fetch that. So this is an H1N1 file. And so depending on whatever scheme you want to convert to, you can click on multiple of those. So I've run it a few times with a few different numbers of things selected. So we'll look at those to see what it looks like. This job runs really fast. So you should be able to get results very quickly. That little arrow at the top of the output file is a great way to go up to the level above. So right now I'm in my highest level, which is all of my workspaces, and you can see there's a few different icons here. So the world icon means that that's a shared public workspace. The workspace icon with the little people next to it means that that's shared just privately with someone else. So like this HA conversion is shared between April and I, and then the workspaces that are private to me look like this little box with the dots. There's a lot of information hidden in the BV-BRC, so definitely take some time to familiarize yourself with things like that. And if you ever want to share information with someone, at the workspace level is where things are shared. So once I submit this job, I'll explain that in a little bit more detail. So I'm going to call this H2. And then you just submit that job, and then it'll say that it's submitting it, and then it'll add it to the job list. What I was just explaining about workspaces is that oftentimes you'll want to share your work with a collaborator, and when you click on a workspace, your green bar will have a little share icon on it. So then you can search for a user and specify if they can either view or edit that, and then hit add user, and now that person will be added. And you see how the icon changed for that one. If I didn't want April to have access to that anymore, I could then go back to share and remove her access and save that. And then that multiple people came off. But sometimes what happens is that we will have a subfolder in a workspace, and you'll want to share that folder with somebody, and you'll see that there's a folder icon instead of a workspace icon. Folders can't be shared, so you can copy a folder somewhere, but you can't share it like you would be able to share a Google Drive folder or sharing a document on Microsoft OneDrive. You have to share the larger unit of the workspace. There's nothing to say that a workspace can't just have one file in it, but if you're ever like, she said I could share and can't figure out how to do it, just make sure that you're actually sharing a workspace. So I probably just talked about that long enough for our job to run. So it took just about a minute. I've run this 3 times with a few different things clicked. So this is the standard output for an HA conversion job. And so you get a blast FASTA, blast output, the input FASTA, the muscle query in and out, and then the results FASTA, and a TSV file with annotation. But we have a report that's generated. And this is where you should look for most of the job outputs that you would run in the BV-BRC. So this eyeball is kind of the standard place to go for the information. So when we click on that report eyeball, you'll get this subtype conversion results. That starts with the query sequence. So here I was looking for H2. It showed the closest reference sequence of H1N1 PDM, which makes sense with our H1N1 sequence. And since I was only clicked one here, there's only one other thing compared to it. It then runs an alignment of those sequences, so you can see those alignment outputs, places where there is not homology between your query and H2, for example. and how they're lined up. Then at the bottom is the numbering conversion result. So the query numbers are lined up with each of the things that it ran against. And then if you look at the beginning, we don't start seeing homology until like 28. So there's a bit of a gap there, but then they start lining up and you can see those conversion results. And so this is with the query, the closest aligned reference, and then 1. And then you can also see what it would look like with multiple. So you see there are a few more lines added in that first section, more rows in the alignment, and more columns along here. You can download the data, either the multiple sequence alignment, the text, FASTA, or the numbering table. You can change how the labels are labeled. So right now, the simplified names or the strain names. So you see down here how that changed. So with the strain names, you have A California 04-2009 versus H1N1 PDM. So feel free to use this tool if it would be helpful for your analysis. It's kind of a quick explanation. We also have a tutorial that has the common name and strains, then a step-by-step guide on how to use the tool, information about the output files, those action buttons that I just went over. So definitely feel free to use those reference guide and tutorials on any of the services. If you're interested in the paper that's associated with this tool, find it right here. And the last influenza-specific feature that I'd like to show you is our surveillance data. So there's a couple of different ways to get to it. The way I like to get to it is by clicking Influenza A under Featured Viruses. And similar to how when I was talking about the green search bar, we have different tabs for certain bacteria versus viruses, or even specific viruses like influenza. So when you are here, you should see the surveillance tab. And so when you click on that, that will pull all of the surveillance data that we have. And from this, you can search and refine. I'd really recommend when you're refining data in our table views to use the filters or the advanced search. The keyword search here is very broad and it'll look through every column. So the last time we presented this, we had some users who were using the keyword search for collection country. They were trying to look for sequences from China. And instead of doing collection country or surveillance data points from China, if you search in the keyword search, it might be that another column has that information. Chile, for example. It would also find Chile in this collector institution column and pull that up. So it's really a not specific way of searching where the filters are going to just be filtering on a specific column. So for this example, and feel free to follow along on your computer, let's look at Bangladesh. And we'll look at the year 2020. And we'll keep everything else the same. And if you want to select everything in a search, you can click the top row here next to sample identifier, and that'll select all 20 pages worth of things. And now on our green bar, we see the map function. So when you click map, that'll bring you to map view of the surveillance data. And here you'll see some different ways that you can click around. So you can do a satellite view or a map. You can show the percentage of positive samples of that surveillance data. So of the samples that were surveilled at a specific location, what percentage of those are positive on this gradient of 50 to 100%, 25 to 50, 15 to 25, and so on. You can click on any of the points and see what percentage were positive. You can zoom into a location. We'll see what percentage was positive. Let's see neighboring locations. You can zoom in and out by moving your mouse or your fingers on your trackpad. Zooming in and out with these features, or resetting the map to what you originally searched. You can also remove or add the labels or the terrain depending on the view. You can also add the flightways. So the migratory wild bird flight paths can be added in. And you can also change the colors of those paths. See that pink is reflected. And so you can see from this surveillance data that almost all of the positive cases were overlapping with the Central Asian flight path in Bangladesh. Just an example for this, or right here on the border of that flight path. So this is just one example of a subset of the surveillance data, but feel free to take a screenshot of this and use it in your analysis for whatever surveillance data that might be interesting to you. One thing I want to show you with the subtype conversion tool is you have to have a HA segment in your job to have it work. So if you run it on a different non-HA, it's not going to work. It'll run the job just as quick as it will, but you'll get this message that there's no result in your folder. So just keep that in mind with the jobs that you're running with that. I believe that's all I have, other than to say that in the workspace BV-BRC workshop folder under viral workshops, you will see a new folder that says back to the basics, and that will have the videos and any jobs that were run, and the presentations will all be there for you to review in the future. If you do have questions in the future, you can email us at help@bvbrc.org or fill out the contact us form. Or if you have a job that fails, you can report an issue, which will generate what happened and hit submit, and someone from the team will help you. But thanks for coming to our fourth Back to the Basics. Here you can see the whole team and all the institutions that come together to bring you the BV-BRC.